Welcome back, class. Today we're going to be starting a new unit, and this unit's going to be over systems of equations. Now, systems of equations, that's just a fancy way of saying a group of two or more equations. And the way that you find the solution to a system of equation is, in the past, we had an equation with just one variable, and is usually x, and we solved and found out what x equals. Well, in the systems of equations, there's going to be two or more equations and two or more variables. And so we're going to have to solve and find not only the x, but we're also going to have to find the y value. So the solution then is going to be the ordered pair x comma y at the point where the two lines intersect. Since linear equations have two variables, then we're going to need two equations to solve for those two variables. So here's an example of a system of equations. There's two equations here, so that's kind of the definition of a system, two or more equations. And each one of these equations has two variables. You can see this first equation has both a y and an x, and this second equation also has a y and an x. So we're going to use two equations to solve for those two variables. One really important piece of information is if both of the equations are written in y-intercept form, remember y equals mx plus b, then one of the easiest ways to find the point where they intersect is to graph both of those equations. So that's what we're going to focus on today, is graphing systems of equations to find the solution. And you can see that both of these equations are in y-intercept form, y equals mx plus b, and y equals mx minus b or plus b. So we're going to be using the graphing method to solve these systems of equations. When we graph these systems, there's three things that could possibly happen. The first thing, and the most common thing, and the thing that we hope for, is that we graph one line, and then we graph the other line, and those two lines cross somewhere. That's what we're hoping for. And where those two lines cross, that's going to be our solution. Okay, so if this happens, then we're going to have one solution. And that means that our lines intersect. All right, so that's the most common thing that could happen when we graph these two lines. Another thing that could happen when we graph these two lines is we graph one of them, and it might look something like that, and then we graph the other one, and it might look something like that, and then these two lines are parallel, which means they never cross each other, they never intersect. So if this happens when we graph, then that means that our solution is we have no solution. There is no point where these two lines ever cross each other, so we don't have an answer. We have no solution. Okay, and this happens when we have parallel lines. Remember, one thing that we know about parallel lines from the last unit is they have the same slope. So both of these lines here have the same slope. So that's one thing you can look for to see if you might have parallel lines. All right, and then finally the last thing that could happen is we graph one of the lines, and then we go ahead and graph the second line, and that second line might lie right on top of this line. They may in fact be the exact same line. And if this happens, remember we're looking for where they intersect, where these two lines cross, and these two lines are crossing constantly. The entire time they're crossing, crossing, crossing. So in this case we have infinite solutions because there's an infinite number of times where these lines are touching each other. So if that happens, we say that these lines have infinite solutions. And that's what happens when both of the equations are the same. Okay, so I'm going to put same line or same equation, but when one line is right on top of the other line, then that means we've got infinite solutions. So those are the three possible outcomes, the three things that could happen when we graph these two lines. We could have one solution, we could have no solutions, or we could have infinite solutions. Let's do an example. Here's an example. You should have this same one in your notes. And in this one, we've got a system of equations. We've got two equations. And we've got a graph here so that we can graph these two lines and see where they cross, where they intersect. I'm going to graph the first one first. My y-intercept is 1. My slope is 1/2, so I'm going to go up 1 over 2. Okay, so I'm going to end up with a line that looks something like that. Then I'm going to go ahead and graph the second equation here, y equals 3x minus 4. My y-intercept is negative 4. My slope is 3, so I'm going to go up 3 over 1. Alright, and so that's the graph of each one of those lines, and the point that I'm looking for is that point where these two lines cross. In this case, it looks like there's only one point where these two lines cross, and this would be my solution right here. Okay, and again, in the last slide we said we're going to write our solution as an ordered pair. So the solution, the answer to this one is 2, 2. When x is 2, my y is 2 in both of these equations. That's the one point that they share in common is 2, 2. So what I'm going to do is I'm going to prove that really quick, and it only takes a second, but you can always check your answer on these problems to make sure that you've got the right answer. So I'm going to plug in 2. I know my x has to be 2, and when I plug it into each one of these equations, I hope that my y ends up also being 2. So let me do it really fast. I'm going to go over here to check my solution. Instead of x, I'm going to put a 2. Okay, so I just rewrote this first equation, but instead of an x, I put my 2 because I know that that's my solution. Okay, so now I've got y equals 1/2 times 2 plus 1. Well, 1/2 of 2 is 1, and 1 plus 1 is 2. So I get y equals 2. Which is perfect. That's exactly what I want. When my x is 2, I want my y to be 2. Okay, so it works for the first equation. Let me try it on the second equation. On the second equation, I have y equals 3 times 2 minus 4. I just plugged in a 2 where the x was. And 3 times 2 is 6, and 6 minus 4 is 2. So I get y equals 2, which is what I want. Okay, so that's how I check to make sure that my solution is right. 2, 2 is the solution to this system of equations. Good? All right, let's try another example. All right, example 2 here. Again, I've got a system of equations. I've got two equations over here, and I've got a graph. I'm going to use this graph to graph both of these lines, and I'm going to see where they cross. So let's try it out. Let's graph the first one. Y equals 4x minus 2. My y-intercept is negative 2. My slope is 4, so I'm going to go up 4 over 1. All right, so my line for the first equation is going to look something like that. I'm going to go ahead and graph the second one now. And the second one, y equals x plus 1. My y-intercept is 1. And my slope is 1, or 1 over 1 in front of that x. So I'm going to go up 1 over 1. Perfect. And again, when I graph both of these lines, it happened again where they cross at one point. Okay, so there's one solution to this systems of equations. And that one solution, I have to go over 1 and up 2. So my x is 1 and my y is 2. So my solution is 1 comma 2. The ordered pair 1 comma 2. I'm going to double check that solution, make sure that it's correct right over here. Okay, so I'm going to plug in, instead of x, I'm going to put in a 1, and hopefully my y value will be 2. Let's try it out. Y equals 4 times 1 minus 2. Well, 4 times 1 is 4, and 4 minus 2 is 2. So that worked out perfectly. When x is 1, y is 2. When x is 1, y is 2. That's good. Let's try the other one. On the other equation, y equals x plus 1. Well, instead of x, I'm going to plug in my 1. And 1 plus 1 is 2. So again, when x was 1, y equaled 2. When x was 1, y equals 2. So that just proves that this is the solution to this systems of equations. I've got one more example for us to try. Let's do one more together. All right, in example 3, again, I'm going to graph two different lines, and I'm going to look for where they cross. Okay, so the first line is y equals 3x minus 5. My y-intercept is negative 5. My slope is 3, so I'm going to go up 3 over 1, up 3 over 1. Connect those dots. All right, there's the line for my first equation. I'm going to go ahead and graph my second equation now. My second equation is y equals 3x minus 2, so my y-intercept is negative 2. And my slope is 3, so I'm going to go up 3 over 1, up 3 over 1. Connect the dots. And in this case, when I graph both of those lines, they're never going to touch each other. They never cross. Okay, they're parallel. And one way that I know for sure that they're parallel is both of them have the same m, the same slope. Both of them have a slope of 3. So I know that they're never going to touch each other. They're never going to cross. So in this case, instead of having a ordered pair for a solution, this one just has no solution. All right, so I hope those examples help. We'll do some more problems in class to practice solving these systems of equations using graphing. But hopefully this is a big help for you, and I hope it comes easy to you. Thanks. Bye.